Alright, today we're going to be learning how to find equivalent resistance. And we're going to be focusing on the two most common types of ways that resistors can be oriented. So the first is going to be series, which is this one up here, and then parallel, which is this one up here. Now, notation-wise, resistance is usually denoted with an R, and the unit for that is ohms, which is that Greek symbol. Now for series resistors, if a resistor is in series, they're just added together. So this resistance, the equivalent resistance of this one would just be R1 plus R2 plus R3. And, any value could be in there. So if they were all 1 ohm resistors, so it would be 1 ohm plus 1 ohm plus 1 ohm equals 3 ohms. And then for parallel, it's a little bit different and a little bit more complicated, but the equivalent resistance for parallel resistors is 1 over R1 plus 1 over R2 plus 1 over R3. And that can go on for however many resistors are in parallel. And the easier way to do parallel, I think, is to combine two of them at a time. So we have 3 here in the top, right? So I'm going to combine 1 and 2 first. And you can do that with a little trick. You do R1 times R2 divided by R1 plus R2. And now that is the combined resistance of R1 and R2 for that instance. And then once you have that resistance, so you can find values in there. So say they're both 1. So it would be 1 times 1 divided by 1 plus 1, so that would be 1/2 ohms. And then you can use this value and combine R2 and R3 in the same manner. Or sorry, R1 and R2 with R3 in the same manner. So then you can go with the 1/2 ohms, and R3, we'll just call that 1 ohm. So it would be 1/2 times 1, which is 1/2, over 1/2 plus 1, which is 1 and 1/2. So that would be, what, 1/3? 1/3 ohms. Now we can look at a couple more practice problems here. And an easy way to do this is to go from the inside out, right? So here you see 2 series, the 2 next to each other up top. So you want to combine these 2 first, and then combine these 2, and then you'll have, so after you do that, you can rewrite it as 1 resistor here, and then 1 big resistor here. And this one is equivalent to all of the stuff in the top. So with the notation here, if you want one big equation for all of the resistance in this circuit, right? If you're trying to write it all out, so Req equals, and then you can also go from left to right, right? So we see 2 ohms. So we get 2 ohms plus, and then we see we got a parallel here, right? So this big thing is going to be 6 plus 10. So that's these guys up here. And then we do in parallel, which is just 2 straight up and down lines with the 4 ohms. And all of that is in series with the 2 ohms. So if we finish this out, we calculate everything. You would PEMDAS, right? You do the inside parentheses first. So this is 16 in parallel with 4, and that's added to 2. And then this 16 divided by 4, since there's only 2 of them, you can use that trick. So you do 16 times 4 divided by 16 plus 4. and that would be, what is that, 64 divided by 20? I believe that's right. My math could be wrong. I don't want to really simplify that. But now that you have that value, you can do 2 plus 64 over 20. And so your REQ for this problem would be 2 and, so that's 4 and, no, sorry, 5 and 4/20ths, which is the same as 5.2 ohms. So that's your final problem. We're going to do a couple more. This long one, you're trying to find the resistance between this point up here and this point up here. So this is a lot of, like, you combine them to get it into the simplest version that you can. So right away I can see that these two right here are in series with each other, so you can combine those two. So this right here, we'll keep that. This right here becomes 60 ohms. And then this one right here is parallel with the 20 ohm here and the 30 ohm here, right? So we're looking for, we can break this down into two parallels and then two parallels. So we'll combine these, all three of these first. Now if I can just erase all of my circles. So we'll do the 60 ohms, which comes from this 40 plus 20, and that's in parallel with the 20 ohms. And that as a whole is parallel with this 30 ohm. So I'm going to do one at a time. We're going to do the 60 to 20. So 60 times 20 divided by 60 plus 20 is, what is that? 1200 divided by 80. That would just be, I don't actually know. I'm going to do a calculator. But so 1200 divided by 80, that's 15. So we have 15 ohms for that first one, and that 15 ohms here. So this is 15 ohms. It's going to be in parallel with the 30 ohms. And so the same thing, we can do 15 times 30 divided by 15 plus 30. And that would be 450 divided by 45. And so that would be 10 ohms. So all of this right here is 10 ohms, equivalent resistance. And now we can see that it's in parallel with this 10 ohms here. So we got 10 ohms in parallel with 10 ohms. And that 10 ohms itself is also in parallel with this 20 ohm. But we'll do the 10 ohm first. So 10 ohms parallel with 10 ohms, that's 100 divided by 20, so that's 5 ohms. And then we have the 5 ohms parallel with the 20 ohms. And that would be 4 ohms. And now we see we've combined everything over here. So everything except for the 23 ohms up top here and the 216 up here. So this value of 4 ohms is everything to the right of this line here. So everything over here is 4 ohms of equivalent resistance. And so we can take that 4 ohms, and it's in series with this 23 ohms here. So we got 24 plus 23 equals 27 ohms. And that 27 ohms is in parallel with the 216 ohms. And so we'll do the same trick there. It's 27 times 216. You're definitely going to need a calculator for this one, probably. I don't know if you're a genius or not. And this final value, so 27 times 216 divided by 27 plus 216, that would be 24 ohms total. So this right here is our equivalent resistance, is 24 ohms for this problem. All right, if you have any other questions, don't be afraid to leave a comment, and have a nice day.